Here's the one single question. Why are we still doing it this way? What we're saying is instead of managing the process and trying to mitigate the exposure at any point in time, why do we need the exposure at all? That's the fundamental difference. That's the fundamental question that we asked right from the beginning. Why do we need that exposure at all? If it's already secure at one point and all the way through the system is secure, but that one point of exposure is your point of weakness. But the question becomes,
Jiri Fiala, CEO of PrivID, leads innovation in enterprise security. PrivID safeguards digital identities, builds trust across organizations, and delivers cutting-edge solutions for secure operations. His vision drives global protection strategies for the future of digital trust. When infrastructure becomes a target, encryption and verification are your best defense.
All right. Welcome to our show. This is your host, Donald J. Kaisamba with the Sync Podcast. And you can always find us on YouTube at Sync Consultants LLC. We want to welcome our guest, Jiri Fiala. He was once here about 9 months ago, where we talked about the surveillance system and I guess we mentioned a little bit about quantum and then the risk of data and its accessibility, right? And making sure that for your company, nobody has access unless they get approval from your team to get access to their data, which keeps everything secure.
not necessarily approval per se from our team. We set it up so that the organization itself has the system that we have put in place for them to grant these approvals, because we don't control the approvals. We don't control any of that. That's not our job, quite frankly. Our job is to put in place those kinds of safeguards and security systems so that the organization itself can do that. Just to clarify, in our last conversation, it was more along the lines of standard cybersecurity type of protocols. I think what you wanted to talk about today, after reading that article, was more about the next level.
Right, absolutely. And we'll get to dive more into that. And again, if you haven't watched that episode, you can watch that and get that from our show at LLC. Please like, subscribe, comment, and share. We'd like to know more from you about what's your context about what we're going to talk about today. And then if you have any other thing else to add to our portfolio. Back to you, Jiri. So we just want to probably reconnect and just see how things have gone so far with PrivID since we last spoke. Anything new and anything before we start?
We're still here, but no, we've done quite a bit. Our presence is predominantly within the European Union and Canada as well, but primarily currently within the EU, given what's going on over there and how they are looking at more data sovereignty and digital sovereignty in a realistic sense. Canada is doing the same thing, but not as aggressively as the EU is currently.
Yeah, definitely. All right, let's set the stakes. So why do you think cloud infrastructure can no longer be treated as political neutral or strategically invisible?
This is the thing. A lot of the cloud technology and a lot of the internet was created in an era where trust was inferred. Everybody just trusted everybody else, right? You trusted that the data was safe. You trusted the data was secure. And when the cloud concept came up, where basically you were just renting space on somebody else's hard drive, you just said, okay, I trust you that this is the case. Now, as that has evolved, your neighbor on that hard drive can be the neighbor that is strategically critical to some sort of deployment anywhere. And therefore, it makes that cloud a target. And by extension, your data becomes a target, not directly, but indirectly as collateral damage. So the question then becomes, if that's the case, how do you protect your data? How do you make sure that data is secure? And the other side of it is that just because you have certain protocols in place doesn't mean that those same protocols apply where your data sits. And so all of these things have compounded to make the cloud a little bit more, I don't want to say dangerous per se, but a little bit more strategic in terms of how you think about the security and the technology that you're going to be implementing when it comes to the cloud.
Absolutely. And I know we talked about this briefly with cloud infrastructure becoming a military target. So when cloud infrastructure becomes a strategic target, what assumption about resilience, neutrality, or vendor trust start to collapse? What do you think about that?
It's pretty clear. Even Amazon told their clients that were on AWS in specific areas, move your data off the cloud. Like they categorically told people, just move your data. there was no ambiguity around move it somewhere that we control. No, they just said move your data. They didn't say move it to someplace else we control. They just said move your data because this cloud is now a target. They weren't kidding. That was really in their best interest, because by doing so, they did a number of things. They told their clients that they care about their clients, right? They told their clients they care about the security of that data. And they told their clients that we will protect your data if we have the opportunity to do so. And sometimes that means that you have to take some sort of progressive steps to make sure your data is protected. So it worked. It was a very solid strategy from Amazon to do that. And the simple fact of the matter is now a lot of organizations are also wondering whether a cloud is the best option for them. And this is the other side of the equation. Is a cloud the best option? And is a cloud in somebody else's backyard the best option for you? Like, you've got European companies, European governments, and so on, and their data is sitting on American clouds. Is that the best option for them? When, especially if those clouds are now a target by somebody else, they're not involved in that conflict. So is that the best place for their data to be sitting, regardless of what they're doing? Is it more strategic for them to have a cloud system that is within their sovereign layer as opposed to somebody else's sovereign layer? And that's the question that a lot of organizations are asking, and governments as well. Because when you are looking at domains, like you and I were talking across a minimum of 2 domains, right? You're in the States, I'm in Canada.
Right.
So we have a minimum of 2 domains sitting between us. Each of those domains has different laws with regards to privacy and with regards to how data is used. I have no control over how your domain uses my data and how it's used over there, and vice versa. The only way for me to control that is to ensure that the domain, that my data stays on my side, right? Because every time it crosses a domain boundary, different laws apply, different rules apply, different politics apply. And each of those points becomes a strategic point of failure, for lack of a better term, and strategic point of exposure, really more precisely, because I can encrypt it all I want, but if it has to be decrypted at every point within the process, that creates a point of exposure, which by extension creates a point of failure. So if you go from one domain to another, that's 1, maybe 2 points of exposure and failure. If you go across 5 domains, that just goes up mathematically.
Wow.
So at each point, at each time that it crosses that border into another domain, it's got to get decrypted to make sure that it's the right system or it's safe to go through that next layer. And so the end result is that you now have, if it goes across 5 domains, you have 5 points of failure, 5 points of exposure, and they don't have to be mutually exclusive. They can be the same thing or they can be separate. So you've got between 5 to 10 points that are now potential access points and can be accessed by anybody for any reason. And that becomes the problematic situation that a lot of organizations and a lot of governments are now realizing is the case. Like I said, in the past, when everything was really like 2006, everybody was still trusting the internet. Even as early as 2014 or as late as 2014 and 2016, people were still trusting the internet. But that's not the case anymore. You can't just trust where your data sits and what's going on with it. So it's a bit of a different scenario now than even 6 months ago when we talked.
Because I was thinking while you were talking, and because we all know AWS is prime, even serious companies, serious established companies use AWS. So when I get as an executive, when I get a prompt or I get a call from AWS says, move your data, what does that mean? And is it an easy thing to do, or where am I taking my data to? Do I need to build a data center, or what does that actually mean? So can you let us know what happens when I get a call from AWS, which that's what most people use, is say, move your data? What are my options and what do I do?
Here's the smartass answer. You change your diaper. That's step 1. But seriously, you need to look at options, right? And you need to figure out, do I have the bandwidth internally within the organization to move all of my data internally? Or do I move it to another? Because just because AWS is being targeted, that particular cloud is being targeted in one specific location, doesn't mean you can't move it to another AWS server at a different location. So AWS does protect you in that sense. You can move it from server to server. Is it as easy as people would like it to be? No, not necessarily, but you do have options, right? So you just have to move it away from that particular server. So it's sitting on this server, but you need it to be sitting on this server. So you have to move it over here. How easy that migration is determined really by the structure of AWS and how much room they have on that particular server, or the proximity of that server to where you are, et cetera, right? So there are other factors. It's not just move it off the server or move it off the cloud. You don't necessarily move it off the cloud. You're moving it off that particular cloud. So it's not that you're moving it from the entire AWS system, but you're moving it from point A to point B within the cloud structure, because the cloud is made up of multiple clouds. So it's not just one cloud per se. These organizations, they have massive centers, data centers in different countries, and each of those are where the data sits for a particular region. So it's not just, you don't just have to go into full on panic mode, but it's like the old saying, just because I'm paranoid doesn't mean they're not after me. You've got to take that into account.
Right. That puts a lot of people at ease, because just that thought of, if I have to take it off AWS, then where am I going? Or that is just as equivalent to AWS would be a channel. I know there's Google Cloud and all that as well, but most companies use AWS for a reason, because of cost, maybe just works a lot for a lot of companies, especially US, and maybe some other firms around the world as well.
Yeah, absolutely. It's the most well-known system. And they have aggressively marketed it as being the domain for your cloud data storage. So Google, although Google was the first one to come out with it, they made it more for the personal side of things. AWS, and that was how it was originally marketed. AWS, when it started, was more of a corporate thing. Even though Google does corporate and does government and so on, it's not as well known as AWS, because AWS was specifically for organizations. It was never meant for a smaller organization like a small mom and pop shop or your personal data. Although that is part of what it's used for, because Amazon is such a massive organization that if you use Prime, if you use Amazon.com, .ca, whatever, your data is already sitting on there.
Right.
In one sense, it's also used for that.
Right, absolutely. Because in my line of work, I've also heard that GCP just costs more than AWS. I'm not sure if the costs have been stabilized, but I guess back I will say 12, 14 months, it was just GCP was a little bit newer in the commercials. And then it just seemed to have cost a little bit more than what AWS was charging. But back to what we're talking about here. So what do you think, how should executive audiences think differently about hyperscale concentration, route independency, and jurisdictional leverage?
Aside from the fact that that's a loaded question, let me put it this way. Okay. And hopefully that'll answer the question in total, but if it doesn't, let me know. When we looked at the old model of cybersecurity and so on, the pipe was always secure, right? Everybody was pretty certain about the pipe. That was never a problem. The problem was always that at the end of the day, in order for you to look at that secure data, you had to decrypt it and it had to appear in plain text. So that was the old system. The problem was that, as I talked about earlier, at each point within its journey from point A to point B, it may have to go through multiple domains. At each of those domain borders, it's got to get exposed to be analyzed and to be confirmed that this, in fact, is okay to go on to the next point. So what you have to do is look at it from a slightly different perspective. How can we get it from point A to point B, validate that it's accurate at each of those points, but not require disclosure? In other words, don't get it into the plain text mode, decrypt it, right? So how do we do that? And so what that really is talking about is the integrity layer, and how, what level of integrity is there straight across the board. And so that's where you have to figure out, what are you prepared to use to maintain that level of integrity across all the domains? And the best option in terms of the new structure, and given where PQC is heading and QKD, quantum key distribution and so on, is to have it so that the data is never exposed, right? It's verified at point A, it's verified across the domains, but it is not decrypted or exposed. It's just verified. And that is the ideal scenario. Now, is that a different way of looking at it? And does that mean a change in the art? Yes, it does. Because you got to remember, we're dealing with architecture that is 30 to 40 years old. Yeah, everybody's put a shiny bow on it now, but it's still 30 to 40 years old. And it's effectively the same stuff. We've just put different interfaces on it. We've put different bows on it. We've put different like shiny lights on it and that sort of thing. But at the end of the day, it's still, the pipe is secure, but at each point within that domain crossing and at the end point, it's got to be decrypted to be looked at. And that's why the entire system has now been built around managing those processes of exposure. Everybody knows that it's got to be exposed, and everybody knows there's a danger that exposure will open your system and that data to an attack. So it's really more a case of they manage it, right? They don't know when it's going to happen. They know it's going to happen at some point, but they manage the fact that this will happen. What we're saying is, let's look at it from a different perspective. Let's say you don't have to decrypt it. Let's just say all you have to do is verify that it's unchanged at each boundary without actually having to decrypt it. And so you verify it at point A, and by the time it gets to point E, it's gone through B, C, D, so on. And at each point, it's been verified by the system, but it hasn't been decrypted. So the exposure to plain text has never happened, which means the system is now more secure. That was the thesis I've been putting forward in the last 6-7 months, which is really more a case of, let's look at the architecture. Let's not look at what everybody wants to talk about, which is that how do we protect the pipe? That's already protected. You don't need to protect the pipe. That's already there. That's already super secure as it is. The points that aren't secure are that point where you've got to decrypt it at the end. And our thinking was, what if you didn't actually have to decrypt it? What if you could just verify it without the decryption process? And so we started looking at how that could be done. And if you look at the things that I've been writing in the last 6-7 months, that's exactly what I've been talking about.
Yeah, exactly. Exactly. Thank you for that newsletter that you post. Is that daily that you do that?
Monday through Thursday.
Okay. Perfect.
Because let's face it, Friday, you're thinking about the weekend, you're not going to read it.
Right.
Or some people, what they'll do is they'll have it accumulate Monday through Thursday, and then they'll read it on Friday, Saturday, or Sunday, or something like that. But I figure just doing it 4 days a week is more than enough.
All right. Stop me if you cover that already. But I think we mentioned that we're going into the plain text problem. So why do you treat plain text as a real vulnerability rather than simply one operational risk among many?
Really, it's not, it can be viewed as one operational risk among many. There's no doubt about that. Okay. But the simple reality is this. And as I said, the pipe itself has been secure and it is super secure. We've made it secure. So there's no denying that is super secure. When do most attacks happen? That's the question that you have to ask yourself. When do the attacks happen? When is your data most vulnerable to attack? It's most vulnerable to attack at the point of decryption of plain text. That's where it is 100% exposed. In that fraction of a second from when it hits a specific domain before it gets to another secure part of the system. And this is more crucial now with AI than ever before, right? AI doesn't need 2 seconds to look at something. AI can look at that same data in 0.005 seconds and boom, gone. That data is now AI's data, right? You don't even need to know that it's been hacked. AI's already done the work. AI's already taken the data. It also read the data, and on it goes to the safe domain where it is safe. You had no idea that the AI system was in the system, that AI was in the system and doing this. And so that moment of exposure to plain text is still that point of vulnerability. It doesn't matter if it's 0.5 seconds. It doesn't matter if it's 0.05 seconds. The point is it gets exposed. And that is a single point of failure, for all systems. What we're saying is let's eliminate that 0.05 seconds. Let's eliminate that 0.005 seconds of exposure. And if you use the architecture that we've described throughout the process, that exposure never happens and it stays encrypted. So your data stays safe and secure regardless of AI being in the mix. Now, is it a 100% guarantee? Honestly, there's no such thing as a 100% guarantee. And anybody that tells you that whatever is 100% guaranteed not to be compromised, realistically, there's no way you can say that. I would love to tell you that it's 100% guaranteed, but I can't, because the simple fact of the matter is hackers are smart. They're very smart people, and they know what they're doing, and they can outthink the average coder very easily and very quickly. Yeah, it's not something people like to hear, but that's the case. They're very smart people. Yeah, some just buy the technology for $10 on the dark web. But yeah, those guys you can get around pretty easily. The actual hackers and hacker groups that are paid by either large governments or small governments or somebody like that, they're smart. They're really intelligent, and they can access your data before you even knew that it was open. So you've got to be aware of that. This is part of the problem, that organizations look at these kinds of things as, okay, so how much is this going to cost me? How much is it going to cost me to upgrade to protect my data like this? How much is it going to cost me to do this? How much is it going to cost me to do that? Here's the thing. You're already paying insurance, and the insurance is there so that if your data gets breached, you've got insurance to protect you. But more and more insurance companies are looking for ways not to pay for that data breach, right? So they're looking for reasons not to pay your claim. And you have to prove to them that you did everything possible to protect your data. But all you really are doing is, within the organization, pointing the finger at the person that was sitting closest to where the data breach happened. That's not really saying to the insurance company, this is what we did to protect the data. So it becomes a very tricky scenario at that point. How do you convince an insurance company you've done your best to protect the data, because the entire system is built around the fact that data gets exposed, data gets hacked. We know it's an issue. We do our best, quote unquote. How do you do that? And when everybody's putting in the same claim, at some point it's going to get very expensive, and insurance companies are going to start looking at what you did or didn't do.
Because I know we mentioned this briefly about that insurance company claims and all that. So sometimes there is a required system that you should get in when you get these policies to ensure that you stay compliant. And I think you guys have designed a system that does pass this insurance claim procedure.
We like to think so. The short answer is yeah. With our system, there's no exposure whatsoever. Okay. But like I said, there's no 100% guarantee this is going to be the case, especially with AI in the mix. But is it as close to 100% as you can get without saying 100%? Yeah, pretty close. And it hasn't been, to be honest, right now, our system hasn't been tested against an insurance policy, because the organizations and the places that do use our technology, they haven't been hacked, haven't been breached. So the question now becomes, is it because our technology is unbreachable, or is it simply because nobody's really targeted these people at this point in time? All I can tell you is that from the systems that we've been deploying in, they're sensitive systems. Nothing's been hacked. There's been some issues, yes, but our system caught the inconsistencies and stop that.
Because if I take you back to the plaintext, because here I'm seeing that where do modern systems still force plaintext exposure in the name of validation, inspection, policy, enforcement, ethics, or convenience? Is that still the case?
Absolutely. Here's the thing. It is the case because, again, it comes back to the old model, right? There's been used for the last 30 to 40 years. And that's never really changed. Our model basically says there's a different way to do it. And we've been working on it for 10 years now, coming up to 10 years. And we've been refining it and modifying it. We're not the only ones, but we've been doing it for about 5 years longer than most other organizations have been doing it. Are we still working on it? Are we improving it every day? Absolutely, we are. And what was the whole goal when I started this was, how do I protect my data? How do I protect me online? How do I protect my family's data online, and so on? And then we started realizing that this is not just about us, it's about the bigger issue of architecture. Exposure is just accepted as part of the process. And we're saying, why is it accepted as part of the process when there are absolute technologies available? And they've been available since 1985. Just nobody thought to use them. Right? And to be fair, in 1985, when these technologies were first developed, the computing power was not there for these things. But today, that computing power that can run these technologies is the one we're talking on right now. It's a phone, right? It's a mobile platform. Computing power is vastly different today than it was when this technology was first developed. So therefore, it now makes more sense than it did way back when. So it's not that it's new technology. It's just now it is finally at a point where the computing power is there to use it. And we have the capability to start using it properly the way it was designed. But like I said, one of the things is we don't just have the one technology. We actually have two technologies that we incorporate and we combine to make sure the data is secure. One is the authentication process and one is the encryption process. And we use the authentication and verification process to ensure that you don't have to decrypt. So we've combined these technologies in a way that is unique so that when the system is encrypted, you verify it at the one end with our technology. You verify it along the way with our technology and authenticate it along the way with our technology. And then when it reaches the final destination, it can still stay in its encrypted state because it's been verified and authenticated throughout the entire process. And so you know that when you've received it on your end, it's been authenticated, it's been verified, it's been all the way through the process. So you know that it's the same data and you know that there's been no issue with it. If anything, with our technology, if anything happens along the way, the system spots it. And the system says there's a problem here. Whatever the problem could be, it could be hardware related. It could be that somebody put in the wrong credentials, whatever. But the bottom line is that the system tells you that this is what happened and this is where it happened. So let's check out if the information is still safe and secure.
All right. So does your system, does it use plaintext or do you guys experience the same plaintext problem we're talking about?
Not at all. Not at all.
Okay. So how is it so? Like, what's the catch around it? Is it cost? What is it?
Cost is a fact at this point. Yes. Is it as huge a problem as organizations make it out to be? Not so much. But what's the real thing that is slowing uptake more than anything else? It's a change in thinking. Like I said, we've been conditioned and organizations have been conditioned to see that exposure is the necessary evil that we have to contend with. And therefore, we spent 30, 40 years managing that exposure and managing that exposure to plain text. And so, yes, we know it's a risk. So basically, it's really about how people think about the system itself. It's a case of our technology is a different way of looking at everything. It's basically approaching the situation from an architectural perspective. It's approaching the situation from the way your system is constructed right from the get-go. And as a result of that, for a lot of organizations, they've got this entire infrastructure built around the fact that, hey, things get exposed. But they don't have an infrastructure around the concept of the data doesn't need to be exposed. It doesn't need to be seen as something that needs to be seen at every step during the process. And that confuses people because when you've got people that are thinking a certain way, this new shift in thinking confuses organizations about how to look at their data, how to look at what they've been doing, and how to potentially work without the fear of exposure of their plain text, right? So it's not that they don't see the benefit, they see the value of it. That's not the problem. The problem, issue, whatever you want to call it. What it comes down to right now for many organizations is they've got an entire infrastructure built around the old paradigm. But that's not the case with certain government agencies, let's just put it that way, especially in Europe, where they're looking at ways to mitigate these kinds of things and looking at ways to secure communications, looking at ways to secure their data, looking at ways to secure their sovereignty of both data and digital. Right. So they're the ones, and this is one of the reasons why we're focusing on Europe, because they're the ones that are now saying to us, your technology does this. Yes. Can we run a pilot? Yes. We show that it works. We go on to the next step. And so that's what we've been doing. We've been running these little mini pilots and we're negotiating right now in terms of going on to the next step for a lot of these organizations. We have about 4 things going on right now that we're just about to close that will essentially do that for various organizations. When I say organizations, it's really government and defense that is looking at this very seriously.
All right. Perfect. Thank you for that. I guess our next segment will be around the context of why control fails once exposure exists. So, why from your perspective, why are access controls, audit trails, and exceptional access mechanisms ultimately responses to exposure rather than cures for it? And I think that's what you've been just talking about. But specifically, why do you think that's happening?
So you're looking at access controls, audit regimes, and so on, right? So again, it comes down to when exposure is required, when exposure is required in a system to function, the controls themselves govern the visibility. They don't eliminate it. Okay. And so an access control says, who gets to see this? An audit says, we recorded who saw it. And then the exceptional access to that, which is the next logical step, is why did the glass break under those conditions? So you've got access control. Yeah, this person saw it. And you've got in systems where privileged access is the norm, that becomes a problem in and of itself, because in many instances, privileged access, just because somebody leaves, has never been revoked. So that account may still have that privileged access, even though it's technically dormant, because for whatever reason, it was never removed from a system. And also, just because you're at a certain level within an organization, say CEO, you don't need privileged access account to everything in the system. You just don't. And that's another point of weakness. And those systems get audited. All those systems, all those audits tell you is who's allowed to see this. It doesn't tell you to what extent they're allowed to see it. When you've got that kind of exposure, the weakness is still there in the system, which is the plaintext concept. So really what you're doing throughout the system is managing access and managing a dependency. You're not removing anything, right? So you can have all of these kind of access controls around emails and stuff like that, but you're not actually removing the problem. The data is still there. The data is still being seen, and it's still in plaintext format. What we're saying is create an architecture where that doesn't have to happen. And we've created the architecture. We didn't create it per se. We just took it in. It was already there. We just took it in a direction that made sense to us more than anything else, which is don't expose anything, verify it at each point, authenticate it. And when it gets to its final destination, you do the verification and authentication there as well, so that nowhere in the process does it have to be put into plain text. It's still decrypted. Sorry, it's still encrypted, and it's been verified at all junctions. And so when it comes to you're on your end, it's verified, it's authenticated, and this is the real thing. There's never been, and there's never an exposure, except when you choose to open it on your computer, not during the delivery mechanism from one boundary to the other, but
Right.
at your point of entry and destination. And we can even set that up in such a way that it doesn't even need to be decrypted there. You can look at the the encrypted data and still confirm that it's the right stuff. So we have that option as well within our system. And that's just another layer of security that's there.
So what does control under pressure look like once multiple operators, laws, or infrastructures can compel access?
I knew that was going to be the next question you were going to ask me. Basically, what it means is that the system behaves like it's intended to behave, which is control throughout the entire thing. Who has access? Is it secure? Is it safe? And that regardless of incentives, regardless of legal demands, regardless of insider pressure, regardless of who's been compromised, the data stays secure. That's control under pressure. Nothing collapses because somebody has exceptional access. The systems, again, it comes back to, is the system secure all the way through the process, regardless of somebody's access point and regardless of somebody's quote unquote privileged access? Absolutely. And that is a control under pressure. So regardless of what domain it's in, that plain text never needs to be revealed. And again, that's control under pressure. And this is why I say we authenticate and verify at each instance, right? So that when it crosses all those domains from, say, one organization, or if you're doing it if you've got a multinational organization and you're sending an email from your, say, Toronto office to an office in Frankfurt, right? And you've got a specific, like a .com, .info or whatever. That's not everybody thinks it's just a direct path. That's not quite the way it works. It's got to route through different servers and different locations and so on. And so our system basically ensures, and this is the core thesis that I've been ranting about for months, that every time it hits one of those servers, every time it hits one of those new domains, it doesn't need to be exposed. It just needs to be verified and authenticated. That doesn't require exposure. And that's what we define as control under pressure. So the data is encrypted. The data is verified through our system. The data is authenticated. It goes on to the next one. Same thing happens there. On to the next one. Same thing happens there. And if somebody with quote unquote exceptional access wants to access the data, they can't access the data per se. All they can access is the verification information and the authentication information. That's it. They don't actually see the data.
Okay.
I don't know if that makes sense. I don't know if that makes sense, but that's the way we view it.
Yeah, it does. But from this question here would be, why do governance-heavy stabilizers often increase complexity without solving the structural weakness underneath?
Again, we come back to they don't solve the structural weakness underneath because the structural weakness underneath is exposure to plaintext, right? As I've said throughout this entire thing, the pipe to get from point A to point B is secure. But each time there is a requirement to decrypt to go to plaintext, for whatever reason, that's a key vulnerability and core weakness within a system. And the more times that happens, the more problems and the more vulnerabilities there are to deal with. So you can't say that, it's 100% secure if, say, at every point at every node within the system, it's got to be decrypted to plaintext to be confirmed and validated. It's not secure. The pipe is secure to get from point A to point B and then from point B to point C. But at point B, because it had to be decrypted and viewed in plaintext, and that's not secure. And then at point C, same deal. That's not secure. Point D, not secure, et cetera, et cetera, et cetera. And that's the crux of the problem that I've been talking about. Point of exposure. And it's baked into the system, really more than anything else. The system was designed that way years and years ago, and nobody's ever thought to change it.
Okay. One of our core topic here, integrity across domains. I guess give us a foundational perspective. Why does that matter, right? Why does that need to happen?
Okay, so let's look at it like this. What integrity across domains, let's look at it from a slightly different perspective. Interdomain trust, interdomain validation. Okay, so it's just another fancy way of saying integrity across domains. So what we're looking at is, in the past, it's been social and procedural. So we just accepted that the trust factor was there and the procedure worked and the procedure was trusted. And from a social perspective within an organization and as a whole, we've accepted that these things are safe and secure, and that the way the system worked was that our data was always protected. So basically, from a trust perspective, we say, we believe this party will behave the way they're supposed to behave. From a validation perspective, we're saying the system can prove what happened, so we trust that the system protects our data. But let's go back to the cloud. In a multi-cloud third-party scenario where you're effectively offloading your data to somebody else, can you really 100% be confident that is the case? So when I say integrity across domains, that's what I'm talking about. I cannot 100% be confident that this is the case in domain A if I'm sitting in domain B, but I trust domain B is going to keep my data safe and secure. But I don't know about domain A.
Right.
I just don't.
So I wanted to really just re-clarify this because we have a lot of executives, CEOs that are they're non-technical, right? What is the clearest way to explain the difference between a path and a domain to a non-technical executive audience?
Yeah, this is where I got to take my nerd hat off and really think about. Okay, so let's look at it like this. Path can be technical, and a domain is an authority boundary. A path is basically how data moves through the system.
Okay.
All right. The domain is who controls that under various conditions. Where is the data seen? How is the data processed? How is the data stored? How is it governed? That's the domain. That's the difference. So basically, you can secure a path with engineering. Then you can secure a domain boundary, but only if you can ensure that the change in control does not require it to be exposed.
All right. So thank you for that. So
I hope that made sense.
Yeah, I think it's clear enough. Again,
at the end of the day, what it comes down to is really straightforward and really simple. You control the data or somebody else controls the data.
Right.
At the end of the day, that's it. That's what it comes down to. And what we're saying is, regardless of where the data sits, how many borders, how many if you want to use the word border instead of domain, that's more or less interchangeable because that's really what we're talking about. Really. In a weird way, we're actually talking about borders as domains and domains as borders, right? So when you go from one country to another, at each border crossing, you have to present certain documents. In Europe, they've eliminated that with the Schengen zone, where I, as a European citizen, as long as I've got my passport with me, I can cross any Schengen border without any hassle whatsoever. I don't even have to show them anything. I just go through. So we basically said, hey, that's not a bad idea for data. Let's do that.
Okay.
And so that's basically where we've taken the concept from. And what we've done, though, is we've just basically said, okay, but with data, it's got to work a little bit differently. It's got to stay encrypted all the way through the process and verify and authenticate throughout the process. So that's really the crux of my thesis and the crux of what we do more than anything else.
Okay, that's makes that's more clearer. Thank you for doing that. So why does integrity tend to reset at borders between jurisdictions, between vendors or operators? Why do you think that happens?
Let's use the border analogy. So if you travel into another country and you're not a citizen of that country, you have to show them your passport. And now for a lot of places, you don't just show them your passport. They also scan your fingerprints. They also scan your face and so on, right? And while all of that is happening, they do all these checks on you. The same thing happens now take that example and put it forward to your data.
Okay.
Because your data at each point basically undergoes this, at each boundary layer, at each domain, at each border, undergoes the same thing, but in a slightly different way because it can happen in 0.005 nanoseconds. But the bottom line is the same thing happens. It's a way to validate and make sure the data is okay to go to the next level. Like it's legal within that domain. And same thing, they scan your face, they scan your fingerprints, they scan your passport to make sure that you're legally allowed to come in. Right. So that's assuming you don't need a visa to go in there to begin with, but that's a separate issue altogether. But the bottom line is that when you just go from point A to point B, that's what's going on. And the same thing is going on with your data. But with data, it's a little bit more critical because you don't know who else could have access to that data and what is going on with that data. Has that system that you're now going through, has that system been compromised? Has that point of that border crossing been compromised by some other agency? You don't know. You're assuming it's safe, but you don't know for sure. What we're saying is let's eliminate the assumption of safety and incorporate into the system an architectural design that says, I don't need to decrypt the data. I just need to verify its authentication and its integrity. That's it.
So this goes back to because while you were talking, I was thinking, why would there be so much ups and downs with the verification of domains or identification of validation if the data is not, because you have different types of data, right? Some data are public, some are not public. And I know from what you're saying, the kind of you should deal with are defense and governments, which will probably in that terrain will have a little bit more stricter guidance with data and how it's seen, who sees it and when, and then maybe how it travels from, I would say, X region to Y region. So do we have those things happening in the public arena, let's say social media?
Yeah, absolutely.
That's still needed, and for what reason?
Absolutely, it's needed because you have countries that heavily monitor social media. You have countries that heavily restrict social media use. You have countries that don't even allow certain types of social media. But here's the flip side to that. Those countries monitor social media. They don't maybe allow you as an average citizen to have access to it the way you would like, but they monitor it. So even if you use a VPN and you get on there, they know you're on there. So your system isn't as secure as you would like it to be. And VPN is definitely going to help you. But in the public domain, that's really one of the few things that you've got access to, realistically. But is it bulletproof? No, it's not bulletproof. Is it going to 100% protect you against everything? No. The simple fact of the matter is just because you use a VPN in one domain doesn't mean that to get into another domain doesn't mean that other domain doesn't monitor VPNs and know where those VPNs originate. I can use a VPN, and I use a VPN to go to different domains and stuff like that and to bounce around. But really super secure system is going to monitor where those VPN nodes came from and where they lead to. It's not as secure as you would like it to be. And most VPNs will only give you 1 or 2 bounces. It's rare that you're going to get more than that. And those can be easily traced, very easily traced. Whereas when you're looking at an organization's data, they don't necessarily use VPNs per se, but they use secure pipelines. But again, we come back to at each point, what happens at each boundary layer? What happens at each domain? What happens at each interaction that is going on? And the same thing with a VPN. Yeah, it can bounce from different points and so forth. But what happens at each of those nodes? Again, what happens there? And so you've got to realize that a lot of these things are just based on architecture that's been around for a long time. And there's nothing really all that new about it.
Because, what I think that I've learned about the internet is a lot can happen because it's not easily, I guess the whole originality of the internet was it wasn't built to be controlled or to have any type of cyber influence until when things started happening in the wrong direction, then cyber came in. But for cybersecurity, cybersecurity, and when cybercrime starts to trigger. So when you're talking about these integrity across domain, talking about domains, are you saying that countries and governments are monitoring their data across their country as a region, or the data as a region? Because I know, like, for instance, AWS have AWS East, South, but how does that all play into, let's say, a non-technical person? When you explain it, this domain and this path here and there, are you saying that countries they have a say into how data is crossed between territories?
In a nutshell, yeah, absolutely.
And
yeah, I know. It's not something that when the internet was created, it was created to allow universities to exchange data and to have a system of decentralized data so that if anything happened to one location, it could be stored at a different location and picked up. And when that other location was back up and running, they could access the data that they had. That was the original use for the internet. And then it grew, and a lot of the people that had been using the internet in university, because way before it became the internet that everybody knows, there were people like me who were using it in university before it was even called the internet. It was just not called the internet. It was just called, I can't remember what it was called, but anyway. But I remember using it in university and thought, hey, this would be great to have everybody have access to this kind of thing. When I was using it, you didn't have a graphic interface. You had to type out 40, 50, 60, 70, 80 characters, and heaven help you if you got a comma wrong at one point, or you couldn't just go back and fix that comma. You had to delete the whole thing and start over.
Okay.
So that was the original intent of the internet. Then Tim Berners-Lee came out with the graphic interface and so on, and that made it more accessible to everybody. But that became the problem because now everybody's got access to it. That was great in theory when everybody trusted everybody that was online and so on. Governments are governments, and governments are going to monitor what's going on online. So that's just the way it is. In order to secure a country or an organization or something, you've got to monitor what is coming and going into your system. That's just the nature of the beast. There's nothing you can do about it. And that's one of the reasons why the whole concept of cybersecurity and the whole concept of security and pipes and so forth hasn't changed in so long, because they came up with that stuff way back in the 80s and 90s. And it was always, this is good. This works well enough so that we can do what we need to do. And okay, so it's been 5 years since we've started this. Why don't we just put a nice, pretty interface onto it and just update the interface on a regular basis? But at the end of the day, it's still the same old technology, right? It's just got a nicer interface really at this point. And there's nothing wrong with it. It's worked fine. But now with the advent of AI becoming more prevalent, with the advent of state actors going after other state actors, which has always been the case, but it's more open now. You've got to be more aware and conscious of where your data is, where it's going, and what is being done to it. And when I say integrity across domains, I'm talking exactly that. Like, how can you ensure that your data is safe going from one point to another? And it has always come back to one critical component: the architecture, right? And so we've looked at it from a different perspective. We just basically said, okay, the architecture and one portion of it works really well, but here's the part that doesn't work as well. which is the plain text. So how can we fix that so that it's as secure as the rest of the system?
Right.
And that's basically where the whole idea came from.
Okay, got it. So as we are rounding things up, so what changes for AI governance if systems can validate conditions, outputs, or state transitions without exposing underlying data?
Okay. So what changes in AI governments
AI
is what you're governance. Yes. Basically what you're asking is how does AI change all of this? Correct?
Yes. Yes.
Okay. A double-edged sword, right? It works really well at protecting your data, but it also works really well at getting access to your data, right? And again, it comes back to that minor point of exposure when you go to plain text, right? If your data has to be accessed by AI to be used in a large language model within an organization, say, okay. Again, the key thing is it's got to be done in plain text. So at that point of decryption to plain text, so your AI can read it, another AI can read it as well, and it may not have the best intentions of accessing that data. So again, it comes down to if you can read it, so can an AI. The difference is an AI can do it a lot faster than you can.
Right.
You tell Claude, you tell Chat, you tell Gemini, and so on to read an article or whatever for you. How fast does it go through that article?
To 0 point.
Right. This is my point. And this is exactly the point, that in that time frame, it can read it, but so can another AI that maybe doesn't have the best intentions and look at your data the same way.
Yeah, that's why you mentioned that the data needs to stay encrypted when it's transferring across domains, so it doesn't expose that plain text.
Exactly.
Right, right. Okay, so it's all coming together. So how should leaders rethink sovereign cloud, vendor to regulator workflows, and cross-border infrastructure in the light of this framework?
What it comes down to really is always this critical component, the architecture. Look at how the architecture works within your organization. Look at where the weak points are. Okay. And there are weak points. But historically, we've always accepted those weak points. So we built an entire cybersecurity infrastructure around it, CSSP, SOC, whatever. Like, there's all sorts of acronyms around that have come up around these weaknesses. This is the ironic part. The acronyms and all these certifications have come about because of the weaknesses within the system, right? So we haven't really learned to get rid of the weaknesses. We've just learned to manage them better. So what we're saying is instead of managing the process and trying to mitigate the exposure at any point in time, why do we need the exposure at all? That's the fundamental difference. That's the fundamental question that we asked right from the beginning. Why do we need that exposure at all? If it's already secure at one point and all the way through the system is secure, but that one point of exposure is your point of weakness. But the question becomes, why do we need that? If we can set it up in such a way that you don't need to decrypt the plain text, maintain the integrity across the domains, maintain the integrity of the data all the way through, and at the same time, ensure that nobody can access it. And if they do access it, they can't read it. Because if it's encrypted properly, nobody can read it. Nobody can read that stuff because they don't have the keys. And if they do have, even with a brute force system, this is the beauty of our technology. Even with a really good system, it's going to take you a decade or so to go through our decryption. I'm not blowing our own horn. This is known about the nature of the encryption that we use, that this is one of its core strengths. So under those circumstances, why not use it? And because we use two different technologies combined together to ensure that the entire system is validated, authenticated, and verified all the way through, there's no real downside to it for you as an organization. Really, more than anything else, is just looking at it differently because you've got this entire infrastructure built around all of this old technology. And to be fair, when you've got a lot of people whose jobs depend upon the fact that their job is to manage your exposure, they're not going to like what we do. They're going to look for ways to not like what we do. So we don't want to put people out of business. We don't want to have people lose their jobs. We would rather work within the organization and say, how can we help your data be more secure without people losing their jobs?
I've seen where people can have a lot of specialists that are monitoring and controlling a lot of that.
Exactly.
Yeah,
exactly. And do we want those people to lose their jobs? No, it's not in our best interest because that just makes us an adversary they really don't want in their system. And we look for ways to work with organizations to ensure that there's minimal disruption. And we look for ways to help with integration of our technology into the existing system. Is it cheap? No, it's not cheap. But will it get less expensive over time? Yeah, absolutely.
So everything. All right. So what is the single,
We hope.
what is a single architectural question that you will want every executive to take away from this episode?
Here's the one single question. Why are we still doing it this way? That's it. That's really it. That's a two-parter, really. Why are we still doing it this way? And two, how can we do it better? That's it. Those are really the two basics. And you can't ask one without the other. And the how can we do it better? I think we answer that. I think we do a pretty good job at answering it. We try and minimize the tech speak as much as we possibly can. And we've learned over time, because we are an organization that is built out of everybody within the organization is really just a tech nerd. So we've learned to speak English, but it's still a process.
All right. So as we wrap up this episode, Jiri, what would you want our audience to know? And we have a lot of subscribers that are within that area that you work in. I would say that EMEA area. So what kind of clients are you taking? I know you're very selective with the type of clients you work with, but what type of clients are you taking? And how can you help nations, or what type of organizations can you help? And what's also going on with PrivID that you want our audience to know?
Okay. Wow. So that is extremely layered and loaded. Let me start with
Down.
Yeah, I'll break it down. Listen, man, I'll break it down for you. And let me just start with the simplest concept. The thing is, the organizations, we're very much of the mind that every organization can use this. But the simple fact of the matter is, the organizations that are looking at this very seriously are large organizations within certain industries that require a certain level of security that is over and above the norm. It's a convoluted way of saying that it's within the government and defense space. And large multinationals. Those are the ones that are currently dealing and talking to us.
Would you add finance?
Oh, yeah. Yeah, absolutely. Absolutely. Finance, healthcare, government, defense. Those are the biggest ones that would make sense for this technology. And that's actually who we're talking to. But is it just restricted to that technology? No, it's not. Once you've got it within those spheres, then you can easily expand it to other spheres. It's not really as challenging to do the expansion. What the challenge is, again, the mindset, right? Is our technology, and we're working really hard to make it a lot less complex. Is our technology easy to pick up and learn? No. But was and all those other technologies 30 years ago easy to pick up and learn? No, they weren't. You had to have specialists in there. You had to have people that knew what they were doing. You had to have a whole group. Now, that's where we get the certification processes. That's where we get the platforms. That's where we get the SOC compliance. That's where we get all that sort of stuff. And so from where it was very complicated to implement, and everybody was wondering why it was costing so much money to implement and so on, now that's the norm. And it's counterintuitive now, because we're saying, hey, just because it's been that way for 40 years doesn't mean it has to continue being that way, because we're saying there's a different approach. And so we want people to think about the fact that there is a different approach. Is it better? I think it is. But does it require a different mindset to implement? Absolutely it does. It requires a completely different mindset, as we've just been talking about. The concept of, you don't need plain text to take a look at something and to confirm that this is what you're actually looking at and doing. So if there's going to be a takeaway from this, really more than anything else, it's that think about the weaknesses that you have within your system. Think about why they're there, and then realize, or not realize, but think about, do they need to be there? More to the point. And the answers to those questions usually come back to the last one, especially, not really. And that's been the crux of what we've been saying. They don't really need to be there. But we're also of the mind that to get somebody to implement this overnight, that's just not going to happen. It's a long process. And that's why we've actually broken it down into a couple of different modules, so that you can have one module, or you can have the other module, or you can have both modules. And so you can implement it different. And you can implement in the entire package, or you can implement one module or another. It's your choice. But at the very least, have a conversation with us. get hold of us and read our Substack. If you really want to know what we think and really want to know what we do, read our Substack and really have a look at it and get back to us. I'm available through the Substack very easily, very quickly. And my email, the best way to get hold of me is by email. It's just the fastest way. So it's just the best option for anybody to do. And really think about, like I said, just think about the technology, think about what could be going wrong in your system right now and understand or ask yourself the question, why does it have to?
Right.
Why does the system have to have this level of exposure at some point? Why does it need to be like this? And then the next thing, once you've asked yourself the why, ask yourself, how can an organization like ours help you mitigate that problem?
Okay. And you guys because you guys built the technology. So if you're implementing it to a new organization, and of course, the organizations all are different and what they will require may be different. But I'm sure you and your team can handle implementation and then also training, right?
Oh, absolutely. Absolutely. We can do this all remotely as well. None of this needs to be done face to face. My team is located in 4 different countries. The Canada, Brazil, Europe. We have 2 different countries in Europe, I believe in Czech Republic predominantly, but we're expanding to the Netherlands as well. We have individuals within those areas and we can do everything remotely. It doesn't need to be on site at all. But if you need us to be on-prem, yeah, we can do that. No problem. If you want somebody there, yeah, again, not a problem. Do we need to be there? No. And training, from a training perspective, yeah, we can definitely handle that. And if you want initially, we can monitor everything off-site for a little while we transition the existing team over within that organization and go from there. We have different ways that we can do it. But yeah, we can absolutely 100% handle it. No problem at all.
Okay. And you have quite an evident amount of use cases to share before you start a project as well.
We have a few use cases we can definitely put forward. Some of them we can't use. We can give you a skeleton of what they do, but we can't use them in the sense of it's an actual demo, but we can show you the system in general. We have a general demo that we use that works, was designed initially for finance, healthcare, and standard communication protocols. We have another demo that is more specific to certain sectors, but that one demo that we have that is across those 3 sectors that'll show you exactly what the system can do.
All right. That's all my questions. And again, feel free did I miss anything you might want to say or before we go?
God, I don't think we missed anything. I think we covered pretty much everything. My question to you is going to be, did I actually make sense as I was
Yes.
talking? Because as I said,
Yes, it makes a lot of sense now that you break it down, not just for me, but for a lot of untechnical people that may be watching our show. So thank you guys for subscribing. I know we reach a vast audience of 50,000 plus people. So thank you guys for continue to watch, continue to subscribe. It makes a lot more advantage for our show with the podcast is on YouTube and everywhere else you may see it. But for the most part, I think it makes a lot of sense, Jiri. The fact that we have countries that have a lot of restrictions with VPNs and just the internet for a whole, and how I'm not sure if fiber optic cable is still the main source of making sure your internet is faster. We see the implementation going on. We see things happening. So you're breaking down integrity across domains and how it doesn't have to be in plain text or what's the exposure to plain text is and how the architecture needs to be more relevant to make sure that you're offsetting cyber influence or hackers influence really all come together. So we really appreciate you for breaking it down, and definitely we'll be reaching out to you once we have some type of client that we can collaborate on when it comes to implementation. So we definitely appreciate you for coming on board.
Listen, Donald, it's been great seeing you again and really great conversations that we have, and I really enjoy it. So if there's another article you like, by all means, just call me and we can have another conversation about it.
All right. Okay. If you paid full price for your last flight, you probably got robbed. I'm Donald from Sync Consultants, LLC. I help entrepreneurs and busy professionals use tech and data to save time and money. And flights are one of the biggest places people quietly overspend. Hundreds, sometimes thousands of dollars a year. just because they don't know where to look. I've been using a site called flightdeals.net. It constantly scans live airline prices and surfaces some of the best deals it can find for your routes, so you can quickly see cheaper options before you book. If you're flying from the US, Canada, the UK, Europe, Asia, or the Middle East for business, remote work, or content trips, shaving even 10-20% off a few long-haul flights can equal an extra lens, an extra conference, or just money back in your pocket. The point isn't magic tickets. It's having a smarter starting point every time you search. I've partnered with them as an affiliate, which means if you use my link to book, I may earn a small commission at no extra cost to you. If you want to stop overpaying for flights, click the link in the description or the pinned comment, flightdeals.net/my-link. Before you book your next trip, this week, this month, or later this year, take 30 seconds to run your route through Flight Deals. Don't book blind. Click the link, check your dates, and see if there's a better deal waiting for you. If you're serious about staying ahead in business, here's the truth most won't tell you. While others consume surface-level content, our members get exclusive access to strategies that move the needle. I'm Donald Kaizamba. After 20 years in AI, I've seen too many fall behind, lacking the right information. That's exactly why I built this community. Members get early access to AI strategies, case studies, and priority insights. The difference is simple. Members act first. Ready to stop scrolling and start leading? Join our community today. Your future self will thank you.
This 60-minute session will help leaders and organizations solve real-world challenges using tailored, AI-driven, strategic solutions. We specialize in business and management consulting, efficiency, scalability, and growth strategies, AI and automation strategy, AI agents, compliance-ready ML tools, workflow automation, executive coaching, leadership readiness, team alignment, and growth mindset, IT and SaaS development, cloud architecture, digital transformation, secure IT design, marketing strategy, AI-powered audience targeting, funnel optimization, brand elevation, change management, digital adoption, stakeholder buy-in, team readiness. Ideal for business owners, government contractors, tech leads, and C-level executives seeking strategy, clarity, and next-step solutions. For the call, to get the most out of this session, please have ready a summary of your business and goals, any relevant documentation or access links, 2 to 3 key questions you want answered, remote, global, certain rules apply according to jurisdiction, starting at $250 per hour Zoom link provided upon confirmation, movie camera explore success stories, youtube.com/@syncconsultantsllc. Let's unlock what's next for your business, your team, and your mission.